Okay, so again, if a cube, if the root and the exponent match, they cancel. And then another thing you need to remember is odd roots. Okay, not odd numbers, not just regular odd numbers, but the root. Doesn't matter what's inside the house, just on the outside. Can have negatives. Can have negatives. So they are allowed. So for example, if you have the cube root of negative x, you'll just you'll make it positive and you'll take out the negative. Yes? Now, even roots cannot have negatives. So for example, if I have a square root of negative x, it's not possible. And the reason being, y'all, is what's negative 1 times negative 1? Positive 1. Don't square roots cancel squares? You can't have a negative square because 2 negatives makes a positive, so it doesn't happen. So if it's negative on the inside, you make it positive still, but it's imaginary. Do y'all remember imaginary from Algebra 2? Okay, so it just becomes imaginary. So it's the same concept, except you put a negative if it's an odd number. So if it's 3, 5, 7, 11, whatever root, that's an odd number, then it's a negative. But if it's an even, 2, 4, 6, 8, it's I. Yes? Yeah, I for imaginary. Okay, last thing that you need to remember before we get started are prime numbers. Y'all, what are prime numbers? Like, what's the definition of a prime number? 2 is a prime number. Okay, but it's because the only numbers that can divide in, the only numbers that are factors of 2 are 1 in itself. So 3 is also prime because there's nothing else that you can divide into that. There's no other factors other than 1 and 3. However, is 4 a prime number? No, because 1 and 4, but there's also 2 and 2, correct? That's why 4 is not prime. So 3 is a prime number. 2 is the first one. 2, 3, 5, 7, 11, 13. It keeps going. There are more. But those are the basic ones. Okay, so those are the things that you needed to remember before we got started. So I'm going to break down some of this stuff way more than we will when we're actually practicing, but it's because I want you to understand why we're doing things, yes? I don't want you to just do it because you've seen it. I want you to understand why, because then it's easier to do yourself. So we know, isn't 36 a perfect square? So how can I rewrite it as something squared? 6 squared, right? Well, then I have x squared and I have y squared. Okay, the rules with radicals, with exponents, not exponents, roots, is that you can separate them as multiplication. So this can be 6 squared times the square root of x squared times the square root of y squared. Like I said, we're not normally going to do this, but I want you to understand why. Well, doesn't the square root cancel the squared? So that's just 6. Square root cancels the squared. That's just x. Square root cancels the squared. That's just y. So there's your answer. Nothing didn't cancel, so everything's out of the house. There is no more radical. Yes?
So with it, like, do you have to, like, separate it like this?
No. I just was doing that because I wanted you to understand why. Okay? You can a lot of times look at this and know this. Like, I know the square root of 36 is 6. I know the square root cancels the squared. Square root cancels the squared. 6xy. That's fine, but I want you to understand why. And that's why I just broke it down. So let's look at example 2. Is 48 a perfect square? No. So you could type the square root of 48 in your calculator. It's going to give you a decimal. Do not put decimals on anything today. We're not doing decimals. We're doing simplified radicals. So I have to do the factor tree. Do y'all remember the prime factor tree? Okay, with the prime factor tree, y'all, I always start with 2. You do you, but I'm going to start with my smaller numbers because then it keeps my like numbers together and it's easier to find my matches. So I know 2 goes into 48 how many times? 24. Yeah, with 2s, the nice thing is you're really just cutting it in half. Now, if you didn't know that, could you have just done 48 divided by 2? Yes, 24 divided by 2 is 12. 2 goes into 12 6 times. 2 goes into 6 3 times. Now, is 3 prime? Yes, once I get to a prime number, I'm done. Okay, that's my prime factor tree. Huh? Okay, now this is a square root, which means 2, which cancels squareds, correct? So I need something to repeat twice. There's once, twice, to come out from under the house. Here's once, twice. Now, does the 3 have another 3? No, so this is a leftover. Well, 2 times 2, isn't that just 2 squared? And that's why when I have it twice like this, I get to take it out from underneath my house. So I circled 2 2's, a 2 comes out. I circled 2 2's, so another 2 comes out. Now, did I circle 2 3's?
No.
So the 3 has to go back in the house. It didn't have a pair to come out. And it's because these are technically both 2 squared, and don't square roots cancel squareds? That's why I took out just 2. Do not multiply them back together and tell me 4. It's not the same. Yes? Okay. Now I look at the letters. This throws some people off, but there's 2 ways you can do it. 2 goes into 6 how many times? 3 times. With anything remaining? No, so it's just x cubed that I get to take out. This is why. If I have 6 x's, I want them in pairs of 2 because this is squared, or square root. So 1, 2, 3, 4, 5, 6. Isn't that 3 pairs of 2? That's why I got to take out x to the 3rd power, because it happened 3 times. So this is technically x squared, x squared, x squared, and I canceled that squared, so I got to take 3 x's out, which is x cubed. Now, y to the 9th. Does 2 go into y pretty? No. How many times? So what's 1 less than 9? 8, because this is 2, so it's obvious. So 2 goes into 8 how many times? 4, with how many remaining? 1. Now, if that's a lot to think about for you, you could have done 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, look, there's 1, 2, 3, 4 pairs and 1 left over. So just like our factor tree, I had the 4 pairs, so I took 4 out, and I had 1 left over. Leftovers always go back in the house. Yes? Now I have to rewrite this, because what's 2 times 2? Bless you. So I have 4x cubed y to the 4th power. Now, I usually leave a little bit of space here, and it's because I don't want your 4th power to make this look like a 4th root. Yes? It is a square root, so make sure it doesn't look like it could be here. Now, number-wise, you can check your answer in the calculator. You can do the square root of 48. We can't type, not that. We can't type letters in here, but we can do numbers, and it gives me this ugly decimal, yes? Well, number-wise, I got 4 square root of 3, and it should equal the same ugly decimal, does it? So my big numbers I did correctly. You can't check the letters in there, but you can check the numbers. Yes? Cool. Now, you do have to be careful, because if this number is not prime, and you could, that will work even if you didn't fully factor it. So just make sure it's fully factored. Any questions with those two? Okay, so let's look at example 3. What do you notice about example 3? There's a negative. What else is different? It's a cube root. So before I needed squares to cancel. What do I need this time? Cubes. I need something to repeat 3 times now, right? So knowing that 81 is not a perfect cube, I did give y'all this in your notes. It's on the back of the front page. So you can look at your cubes. If you notice, there is no 81 in my cubes. Okay, it goes 64 to 125. So 81 is not a perfect cube. So I'm gonna have to factor tree it. Now, I also have a negative, but it's an odd root. Is that okay? Mm-hmm. When it's an odd root, remember, you'll make it positive and just take that negative out. Now, I always bring my negative down, because if you're like me, you will forget it. And we have to break down 81. Well, 2 doesn't go into 81. What's my next prime number? 3. Does 3 go into 81? Yep. And again, if you're not sure, you can always divide, and it goes into it 27 times. So this is 3 and 27. Does 3 go into 27? How many times? And then 3 goes into 9 3 times. 3 is prime, so we're done. Now, I'm looking for something that matches 3 times. Well, look, I have 3 3s right here. But I have one remaining, and that's okay because that just goes back in the house. So what do I get to take out? The 3 that I circled. But I know I have to put a 3 back inside my cube root. Now, 3 goes into 9 how many times? 3 times. Pretty, right? Nothing remaining? Yeah, and if you needed to, you could have done 1, 2, 3, 4, 5, 6, 7, 8, 9, and you see that you have 3 groups of 3, so that was nothing remaining. Now, 3 goes into 5 how many times? Pretty. Just once with how many remaining? 2. Now, again, if you need to draw it out, draw it out. 1, 2, 3, 4, 5. That was the one group of 3 I got to take out, and we had 2 left over, so I have n squared back in the house. Do I even have to rewrite this one?
No.
No. Because there was nothing to simplify. Now this one has a negative, but it's already on the outside. Is that okay? Yeah, we just bring it down. Doesn't matter what the root is. If it's already on the outside, it's fine. Okay? But I have to break down 32 because 32 is not a perfect cube. 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. 2 goes into 4 2 times. 2 is prime, so I'm done. This is a cube root, so I need something to match 3 times. So I have 1, 2, 3 2s. And I have 2 2s remaining. They don't have a third one to circle, so I can't circle them. So I'm going to take a 2 out. But what do I have to put back in my house? 2 2s. And these are factors because it's our factor tree, which means I'm multiplying. What's 2 times 2? So I put a 4 back in the house. Okay, 3 goes into 3 how many times? With nothing remaining. 3 goes into 5 how many times? Once with how many remaining? 2. Be careful if you need to draw it out. You can. There's 1 that I got to take out and the 2 remaining. Don't need to rewrite it, so here's my answer. Okay, we're going to do number 5, but we're not going to finish number 6. We're just going to talk about it because I'm going to change it anyway. Okay, so I already have a -4 in front. That's fine, y'all. And there's no symbol in between. And when there's no symbol, what does that mean? Add, subtract, multiply, or divide? Multiply. So I'm going to bring down my -4, and I'm going to put a dot so I don't forget that I'm multiplying it. Yes? Now I have 160. And I had people ask, do I have to start with 2? You don't. You can start with any numbers. They don't even have to be prime numbers to start. However, every end of a piece, when you're done breaking it down, see how all the ends that don't have another tree branch are prime? That's how it has to end. I just like doing it this way because they all line up nicely and they're easier to see. If you start doing like 8 times 20 or whatever, you get like different levels and it's harder to find all your prime numbers. So this is just my preference, but you can do it whichever way. So I know 2 goes into 160, and when I'm doing 2s, I'm just cutting it in half. Half of 160 is 80. Half of 80 is 40. Half of 40 is 20. Half of 20 is 10. Half of 10 is 5. 5 is prime, so I'm done. Well, what kind of root is this? A 5th root. So I need 5 2s. 1, 2, 3, 4, 5. I have 5 2s. So I get to take it out. But what do I have to put back in my 5th root? The 5. What was left over? Now, 5 doesn't go into 6 pretty. So 1, 2, 3, 4, 5, 6. Okay, I know that I have 1 I get to take out, and I have 1 left over. Now does 5 go into 15 pretty?
Yeah.
How many times? 3 with nothing remaining. So this gives me negative 8 xy cubed 5th root of 5x. I told you I was going to change this problem. We're not going to even do it all the way. I just want to have one conversation with it. I have an even root. This is 4. And I have a negative. What do I have to do? Make it positive, but do I put a negative on the outside? I put an I for an imaginary because it's a 4 root, which is an even root. Yes? So I'm going to have 6i, and then I would keep going. Yes? We're not going to keep going because it's repetitive and redundant. It's the same thing we've been doing. But I wanted to have that reminder of if it's negative on the inside, that's why I changed the problem, we would take out an I. Yes? Okay, any questions with that? Okay, cool. You have a practice. It's on the back. Oh, there is one I want to talk about really fast. Flip over and look at number 3. Okay, it's a fraction. Is that okay? Yes. Just like with number 1 in our notes, y'all, I separated the multiplication. If I can separate multiplication, do you think I can separate division? Yes. So I can rewrite this as the cube root of 27 over the cube root of 64. Well, you don't even have to factor tree these because you can always look here first. Is 27 a perfect cube? So what's the cube root of 27? What's the cube root of 64? So this just becomes 3 over 4. Does that simplify? No, so there's my answer. On the first row, 1 through 8, only one of them after you simplify has a root left. Only one. Yes? Okay, the rest of them end up being pretty, so don't stress about them. Yes? Now the other side, they all have roots. Okay. One more thing is look at number 1. It's negative, but it's an odd. Is that okay? So I take it out as a negative because it's odd and it's allowed. What is the root? Doesn't even matter which root. This is a cube root of 1. Well, y'all, what's 1 times 1 times 1? 1. So 1 cubed is 1. And doesn't the cube root cancel the cube? Y'all, anytime you have, doesn't matter what number, or what root number, if there's a 1 on the inside, guess what? 1 is your answer. Okay? 1 is like a perfect square, cube, 4th power, 5th power, 6th power, 7th power. Doesn't matter. Okay? So it can come out every single time. Any questions? Okay, cool. This is what you're working on.